1. First off, in number 1, someone did point out to me that I had started number 1 wrong, in that it should have been 2x plus 2 plus x plus 2, and it says the white ones represent y, which means that would be plus negative 2y, or you could have had minus 2y. So if, that would be the answer to number 1 right here. This whole thing is the answer to number 1. So that then if I'm doing number 2, it says simplify that. I would notice that I have 2x and x, which gives me 3x. I have the other two like terms. The other two like terms would be the 2 and the 2. So I have plus 4. And then I can either write it as a minus 2y, or I could have plus a negative 2y. I could have either answer as it is, as I'm writing that. Okay? If I am looking at number, I would take all of these are from C2, right? I mean, we only had C2 as an assignment.
Yeah, on the back.
That's
also C2.
That's
There's 3 things.
okay. So if I'm looking at number 5 here, as I look at number 5, was that one of my questions that someone has up there?
Yes.
Okay. So if I'm looking at number 5, in number 5, if I look at that problem, I want to add my like terms. And so when I look at number 5, the like terms. So if I ask you today, and we take that quiz with the phrases that we didn't take on Monday or on Friday, we might take that today. It's not going to be with the terms and like terms, but if I was looking at number 5, in number 5, I might want to say, oh, you know, these are my S terms, and I have this minus and negative. So what I'm really doing is taking 13 plus 9, and then that has an S with it, and then I'm doing my T terms, and I really have a 6 minus 4. Now someone said, could I put a plus negative 4? Yes. So that when I add these two together, I should have had 22s plus 2t. Okay. Number 9. Number 9 says 13x minus 7 plus 5x minus 17x. These are my 3 like terms, which means I'm taking 13 plus 5, and maybe plus a negative 17 might be better for some of you to think of that subtraction that way. And then we have a minus 7. So when I look at my answer for number 9, I should have had,
This isn't ours.
Oh,
Ours
this
is
isn't
I would
yours.
give a 13.
Ours is number 9 is
Number
this
9
one.
is the
Oh, number 9 is the,
For each hour that Joe worked.
yes, yes. Where did that one come from?
I was wondering.
So this number 9 is right here. Write an expression. This is 9 and this is 10, right? So, my fault. So number 9 says, write an expression for this problem. When you are doing that, we want to start with what happened first. So you have to use all the numbers when you're writing it. So he started making money, he's making $12. Then for trimming the tree, does he get add 9 or subtract 9? Add. Then he has to pay for his gas. If you have to buy gas, do you make money or lose money? You're having to pay that. Minus 5, and then you got a bonus of 20. So this is 9. Because you did that in less than 4 hours. So now if we are adding those together, I don't care. You can use the commutative property and rearrange it and add the 12 plus the 9 plus the 20 and then subtract 5. You can add all your positives and then subtract 5. Either way, as you do this, you should have an answer of $36. Yeah.
So number 9, wouldn't it be 5x? Because it says 5 per
But it said he had to pay,
It doesn't say how many gallons.
Yeah.
so could we have this as 5x? I would take that. I would take it if you did it that way, or if you just had 36 here. Or if you did, I would take, how Maria was saying, and do 12 plus 9 plus 20, and then minus 5x, which means when we add these two together, or those 3 together, we should have had 29 plus 12, which would give us 29 plus 12 gives us how much? 41. So I would have had 41 minus 5x, or I could have had just the 36. I would take it either way. Okay? Yeah.
The bonus, maybe we doubled his amount of pay.
So, looking at that bonus part, the challenge. Oh, his bonus? Yeah, they gave him lots of money. They were nice neighbors, weren't they? So, as we are taking a look up here, it says write an expression based on these instructions. Add 3 to x. That's this. 3 to x. Then subtract this result from 1. So this result, put it in a parenthesis, please, and take 1 minus that. Then we're going to double it. Oh, so now if I double this, that means I'm really thinking of doubling this whole thing. I get this. Now, this is kind of ugly, so inside this parenthesis, we're going to do our work first, and I'm going to put this 2 out in front. And if I did that in front of this parenthesis, that's going to give me 1. And if I have a negative in front of a parenthesis, that actually changes everything to the opposite. So that's going to be 1 minus x and minus 3. I'm going to have 2. This negative changes everything inside. It's like multiplying by -1 to an opposite. So write this down with me. So, yep. I know, we're simplifying it. We're simplifying. So we write this expression. Yep. It says we're taking, subtract the result from 1 means I need the 1 out in front. Okay? Good question. So, this one, and if we were going to simplify, you kind of keep going. If we're doing part B, it says add 3 to x. So x plus 3. It says then double what you have. That you're taking it times 2. Then subtract 1 from the result. Are these going to be the same, do you think? At the end? Probably not. X, okay. This one says, if we multiply this fractional thing by 4, we get 2x plus 3. Is 2x plus 3 then equivalent to that? So, if I take x over 2 plus 3/4, and I take this whole thing by 4, which really means I'm taking 4 times x over 2, and I'm taking another 4 times 3/4. And if I do that, and I multiply this out, I'm actually going to get, this 2 goes into 4 twice, and I get 2x. And here I get 12. So the question is this equivalent to this? When we are looking at, are they equivalent expressions? It's going to be more equivalent equations, but this one is 4 times more than this one. So are they exactly equivalent? No, not really. Yeah. I know, I did say yes. It should probably be a no, because this one is 4 times larger. Yeah. I can. So let's look quick at number 6. The only like terms are the 4 and -7. So if I'm writing that, I'm going to have 11x. I'm going to have the y term next. And it doesn't really matter if you put them in exactly that same order. So I'm going to have the 11x. I'm going to have plus 3y. And I have, when I was looking at this, my last terms, I had 4 minus 7, or 4 plus a -7, which is a -3. And again, you can have -3, or you could have plus a -3. Now, if you have not checked this on the daily planner, I need you to do that. I'm not gonna do that in class. I wanna get to the lesson. I wanna get your tests back to you. I wanna talk about those tests, and I want to possibly do that homework quiz that we didn't get done on Friday. So, as you are looking at the distributive property, we've done commutative, we've done associative, okay? We are now looking at the distributive property. So, yes, you did not. So, it's on the bottom of page. So if I'm taking a look at the distributive property, it says I can define a term. What are terms separated by? Terms are separated by what? Addition and subtraction. So when we can define a term, remember, term is going to be separated by addition and subtraction. The coefficient is what? If I'm looking at that, raise your hand. Where is the coefficient? The number, and we're usually going to say it's the number times our variable, okay? So it's the number that's being multiplied by that variable. And what we're going to be doing today is looking at different ways of writing this expression. So an example of the distributive property is this. They have the 7 times the whole quantity, a plus 5. And what that really means for distributive properties, please put these arrows. This means we're going to take 7 times a, and we write it this way, 7 times a. And then we are going to take 7 times 5. So write it just like that, put those arrows. 7a times 7 times 5. So if we multiply 7 times a, that is simply going to be 7a. And then our simplified answer of 7 times 5 would give us 35. So when we are looking at this problem, it says the distributive property can be used to simplify expressions. How do we simplify? Simplify often means eliminate the parentheses, okay? So we don't want to have parentheses. There's going to be other times that we use the distributive property, and we use the distributive property to solve a problem by taking something and then either doing addition inside here to solve by factoring. Okay, so sometimes we use the distributive property to have something out in front times something that we factored. Other times you're going to be using it to eliminate the parentheses. Okay? You're going to see both in our homework tonight. There's sometimes when it's going to say simplify using the distributive property. So if you look at that next page in your notes, what it says is that if A, B, and C are real numbers, which means they could be a fraction, a decimal, okay, and we take A out in front, when the two things are next to each other, it means multiplication. So the distributive property, what we are looking at, is distributing A. So it's kind of like, gentlemen, I need your attention, not making noises. This is kind of like when I distribute your test pretty soon, right? I'm going to distribute or your homework when I'm handing out the notebooks. I distribute to this row, then I distribute to this row, and then I'm giving them to each row. By the way, those of you, if you haven't made up your tests, I did put those in as a 0 at this point, so I'm hoping that will maybe encourage you to come in quicker to get your stuff made up for me, okay? So if we are looking at this in your homework today, you're going to be asked to do this. You're going to be asked to use the area rectangle to model the distributive property. So one of the first things that we are looking at is if I was going to write this. This one could be using the distributive property, 8. So right below here, let's write 8 times. I'm finding the area of a rectangle, x plus 5. So if I'm finding area of a rectangle, that's one way, using the parentheses. The second way is finding the area of each of these. So the area of this square is 8 times x plus the area of this square is 5 down here, but this side is still 8. So we have 5 times 8, or they might have 8 times 5. So it says draw a rectangular model to show this problem. So right down here, we are going to draw a rectangle. You want to have 2 sections kind of like they did up here. So the one length here is x. This length will be 2. We don't know how long x is. We don't know if this is drawn to scale or not. But if we're finding the area, the 5 is out in front. So that's how we're going to model it. And then it says, okay, so now let's show it written another way. So we take 5 times x plus 5 times 2. What you want to remember is you are distributing. By putting these arrows, that means you have to multiply it by both of them. The most common mistake that people will make is they'll take it times the 5 times x, and then back here they'll put a plus 2. So if I'm simplifying this answer, my answer would be 5x plus 10. Okay. Now, on your homework today, on this page, I need you to write something. You got a little more room still? Okay. Over here, on your homework today, you're going to have this problem. It's going to look like this. It's going to say, use the distributive property to evaluate. So you're going to be asked to evaluate. And the problem will look something like this. With no calculator, do 4 times 198. No calculator. So, if we are going to use the distributive property, please make sure you're writing this down. Some of you aren't writing this. Right in that space, right below there, you need to write this. So that when you do your homework, you know how to do this tonight. So you're going to use the distributive property. And we're going to use it, and we're going to factor this time instead of getting rid of those parentheses. We're going to use the parentheses. We're going to use it instead of 198. What is 198 really close to if you were going to estimate it? 200. So we're going to go 200. 200 minus what gives us 198? 2, right? This is a much easier problem to do, right? Can you put that below your desk so if I walk back over here again, I don't put things. So if we are doing this, we are going to take 4 times 200. Well, 4 times 2 is 8. This is going to be 800, right? Minus 4 times 2. And do you see how we can easily kind of do this in our head and get an answer of 792? And now you could check this on your calculator, but today in your homework, when they give you this problem, this is what I need to see. If I only see the answer, then I know you probably use your calculator, right? And I really don't want you to do it that way. Yeah.
You can also do like 4 times.
All right. So I notice on some of yours, you have a lot more room right up here. We're going to do one more question up here, okay? So, like this one, we're going to do one more. So, it's going to say, evaluate, again, using that distributive property. And the problem this time will be something like 3 times $12.03. Okay? So, how can I write it using the distributive property? I'm going to go 3 times 12 plus, and then back here, I'm going to break this down to 3 cents. I was thinking it was 2 cents, but it's 3. So we're going to write it out this way. 3 times 12, do we know 3 times 12 pretty easily? 36. And I'm now going to take 3 times 3 cents. Well, 3 times 0.03, that's going to be 0.09, 9 cents. 36.09. Now this one probably you could have done without the distributive property. But when you get something like maybe a different question, and I don't want to give you one that's in your homework, but if I was looking at this one like 9 times 7.97, and I have to do that without a calculator. Lucas, let's write this one down. 7.97, really close to what? 8. Do you have your glasses with you today? Okay. Make sure you bring those. 8 minus how many cents? 0.03, right? So we're going to do our multiplication. We'd have 9 times 8. We're in your notes. We're not in this. We're in the notes. We're doing this on here, right on that page. Okay? So we're going to take 9 times 8 minus 9 times 3 cents. 9 times 8, if we are multiplying, gives us 72. Then we have to subtract 9 times 0.03. What's 9 times 3? 27. So this is 0.27. So our answer, if we're subtracting it, is going to be 71.73.
Yeah.
And this is how you'd show it. Now, could you check it on a calculator?
Yeah.
Definitely. But what I want you to see is how, when we don't have a calculator, how we can simply do some of the math by doing the subtraction part and looking at that problem. Okay? Should it be 63 or 73?
1.73.
Question.
Why did you subtract?
Because up here, to get $7.97, 8 is really close, but it's 3 cents less. Whereas here, it's 3 cents more. Okay? Alright, so let's continue. So, method 1. You're going to have some problems, and sometimes, before when we talked about PEMDAS, remember, order of operations?
Oh my god.
Okay? Order of operations. Yes, I do need to stand back here more. Order of operations tells us that when we do this problem, we can do inside here, right? Because 3 and 4 are like terms, and we can have 2 times 7. So if I'm writing it, I can do it this way, 2 times 7 and get 14. The second method is to distribute it, okay? By distributing, I can see that I can take 2 times 3, if I'm looking at this, and then I can take plus 2 times 4, gives us 6 plus 8 or 14. Both answers are the same. It says you get the same answer both ways. However, if you use a variable in your math problem, the first method we cannot use to simplify, okay? If there's one of these is not a like term, then you can't add those. But if they are, then you can always add those together. Most of ours, the reason we use distributive property is these are not going to be like terms, okay? So, we're going to look at a couple of questions. We are going to look at this page, and then we are going to look at just one other thing for tonight, and then we are going to get you started. So, if we start this one, to simplify the expressions, we want to take 2 times, what number's in front of this y if there's no number? 1. So that means 2 times 1y plus 2 times 4. 2 times 1y does give us 2y plus 4 times 2, 8. This would be my simplified answer. Yes?
Can you just skip the part where it's 2.1y or 2 times 1y and just put 2y?
I'm going to have you today, as you do this to start, I'm going to have you write out and show me what you're doing. Because I will have students, when they get more complicated, make mistakes. So, and I don't care if you want to do it right behind the problem or if you want to do it below. So in this case, what I want to see is that we are taking 12 times 3. So a lot of people, no problem. 12 times 3, they get to 36. Then it's a minus, and you're taking 12 times. Those of you that aren't writing, put this on your paper so you don't have to look at it later. Even if you don't quite understand, write it down now. Because you can always go back and change your notes or add to your notes. So 12 times 3, no problem, 36. This is really like 12 over 1. So if I am looking at that, I want to, as I multiply those fractions, I really get 12 divided by 6. Well, 6 goes into 12 2 times, right? So I really had this 12 over 6h, which is really going to be 36 minus 2h.
So,
Just wait. I'm going to have you show this one. So again, what should I put out in front of this one as I start looking at this? I'm going to start with 3 times 0.4. The 3 this time is way in back, but it still means you're distributing. It's like me standing in the back of the room and passing out papers from the back instead of the front, right? I'm still handing them out to everyone. So 3 times 0.4 plus put down that common number that's out in front, 3 times the 1.1z. 3 times 4 is 12. This is going to be 1.2. 3 times 1.1z should come out to be 3.3z. If I asked you how many terms, we have how many terms here? 2. They're separated by an addition sign.
Okay.
If I ask you for the coefficient of z, the coefficient of z should be, Lucas? 3.3. If I asked you what is my constant, what is my constant in this one, Jessica?
1.2.
What did you say?
1.2.
1.2. Okay. So we are going to multiply this one. It says we are taking 1/5 times 5x and then 1/5 times negative 15. So we're going to have 1/5 times. Can you write 5x as 5x over 1? Definitely. Minus 1/5 times 15 over 1. So when I look at this problem, I look at it and I go, oh, 5 over 5, that is the same as 1. So 5 divided by 5, I'm going to be left with 1x. 5 goes into 15 3 times, and 5 goes into 5 once. So my answer in simplest form would be 1x minus 3. Could you leave it as just x minus 3? Yes. If I asked how many terms, Maddie? My answer, how many, Maddie? So do we have, terms are always separated, we said, by addition and subtraction. So how many terms do I have? I have 1 subtraction. I have 2 terms, okay? If I'm looking at the number of, if I want to look at, so I have 2 terms. If I want to look at my coefficient of x, coefficient of x, Grace, should be 1. If I wanted to get the constant term, Emily, should be
3.
really close. Not 3, but it should be, Kylie, -3. And that's always kind of tricky for that, okay? So making sure you're realizing those, okay? We're gonna, don't write on this, just leave this for right now. We're gonna come back to that, okay? This is what I want you to look at, is this part with -1. So if I take any number except 0 and I multiply it by -1, it gives me the opposite. -1 times -5 is positive. -1 times 6 is -6. And this one just always stays a 0. So when we simplify these, what I want you to do is write out in front, put -1. So change that right behind there and put -1 right behind the problem, and put times 2x plus y. So if we are distributing that -1, that means what I'm looking for is to take -1, and I'm multiplying it, yes, by 2x. I want you to write it down in tonight's homework. Plus I'm taking -1 times y. Someone said, can I put a 1y? Yes, or you can just leave it as y. I'm going to have -2x plus a -y. Oh, but I don't like having this plus negative. I will take this as an answer and I would not mark it wrong all this year. As you get into algebra and you're simplifying my algebra students, I'm still okay if they do this because they make a lot less mistakes with the plus and negative than when they do a minus. But this answer would also be correct, 2x minus y. Both of these are correct answers, okay? I would take it in either form. So what I want you to do right now is do the same thing with this problem. So we might rewrite it first as -1 times -3 minus 4u. What should I have for that solution? Because it changes everything to the opposite. Do that right now, telling me what we should have for a solution when we take everything to the opposite. Opposite of both of those. Now, I can show that by taking -1 times -3, which is going to give me a +3. Then if I keep this minus right here, and I keep that in the problem, and I put -1 times 4u, negative times this minus a negative becomes a plus, and I do get a +4u as I'm looking at it. I would like you right now, if you would turn in your workbook. What is the distributive property? Give an example showing both the factored and expanded form. So that's kind of like giving me an example of that rectangle. Okay, that's what I'm looking for. Okay? When I look at 5, so this is really question 1, and then they're not really numbered. So this is number 2, and then there's like, second, then I'm going to have, this is like problem A, okay, if you want to think of it, B, C, D. Then this is going to be number 3. Then you got like 3A, okay. So this is going to be number 4. I don't care if you letter them going across. If you go to the back, the rest of that page, this would be like the number 5 and the number 6, okay? So on the front of this, you really have question 1, 2, 3. This is right in your notes, right? What we were looking at. How do we do 7 times? This was on the first page of the notes today. So C3 notes, okay? Page 1 that you had. Page 1 and page 2. It's right on that first part of our C3 notes where we did some just like this, okay? Same with the rectangle. I need to see it both ways. Oh, then down here, number 4, write each one in expanded form. What expanded form means is no parentheses. Then in question 5, if you think of question 5, everyone see where this one is? Put a number 5 out in front and says, write each expression in factored form. Oh, factored form. We didn't really do that, right? What they mean by factored form is, what do these two have in common? The biggest thing they have in common. 4x and 16. The biggest thing they have in common is 4. Then put a parenthesis. What would I have to take times 4 to get 4x? No, just x. What do I have to take times 4 to get a plus 16? So this is what they mean by factored form, okay? That's what you're doing for each of those questions going across. Then down here it says, 3 of the following are equivalent. Explain which expression is not. So what you're really looking for is one of these is not the same as the other. I could do the song.
What?
One of these is not like the other. Have you ever heard that song?
No.
No. You guys need to do a little more PBS. Anyway, I think that was even on, is it Sesame Street? One of these things is not like the other. Okay. All right, so good.
I know it.
So you're going to tell me, and then you have to explain. That's the key part, okay? Please turn the worksheet over. This is where when someone was asking, do I have to write out and show my work? This is why I need that with the distributive property. Because we're not just going to do the distributive property. We're going to get it into these expressions, and we're gonna combine like terms and do all kinds of stuff with it. So it gets really ugly fast, unfortunately, okay? So as part of our standard is we work with this. So as you look at these, I would like to do this one with you. And then the rest of the time is going to be yours to work, and I'm going to hand back the rest of your test. So, 4x. Write this one down so I can help you with your homework. Anytime where there is subtraction, we're going to always change subtraction to add the opposite. So I'm going to put these as both plus a negative. I would recommend you doing the same. Anytime you have subtraction, change it to plus a negative. So I have 4x, and I'm going to put plus negative 7. And I'm going to take that times 3, right? We're distributing this one. Do I take the negative 7 times this negative 9 too?
Sure.
No, it's not in the parentheses. So, we are going to we're going to put a plus sign because there was a plus here, so we're going to put that plus. Then we're going to put negative 7 times negative 3x. And then we have this plus negative 9. Mrs. Thompson, do I have to write all this? Why, yes, you do. That's why I'm helping you with this. Oh, so what does this look like? 4x plus, this is negative 21. You got to simplify it. This is positive 21x. Plus negative 9. And now you're doing like you did in today's homework. 4x plus 21x gives us 25x. Negative 21 plus a negative 8. They're both negatives plus a negative 30. I would accept this answer. I would also take 25x minus 30. I am going to be handing back